Welcome to Unite Now, where we bring unity to you, wherever you are.
Hello, and welcome to First Steps in XR. My name's Dan Miller, and I work as an XR Evangelist at Unity. Later, we'll hear from Jacek, who works on the education content team, also at Unity. Now let's give a brief overview of what we'll cover in today's presentation. First, we'll talk about Unity's XR platform, how it's evolving, and how we're continuing to integrate new platforms into Unity. Next, we'll dive into the XR Interaction Toolkit, showing you how to get started with this new interaction toolkit, as well as walking through a world interaction demo that's built as a sample to learn from. Finally, we'll hear from Jacek, who will go over the Education Creator Kit project and walk through building and extending the XR Interaction Toolkit by rebuilding a small object. Unity's XR platforms has started to evolve as new platforms continue to expand and add new features. What we've noticed is that devices share a common set of features between augmented and virtual reality, and that these new features continue to be released and refined and updated at a very accelerated pace. So what are we doing? At Unity, we're giving you an XR provider layer, which is a standardized set of APIs for the specific platforms. Here you can see the ARKit Raycast subsystem, ARKit Camera subsystem, and ARKit Session subsystem. But more than just giving you direct access to the APIs and the platforms, we're also building what we call Unity's XR developer layer. And this is a single framework that sits on top of the platforms and abstracts them in an easy-to-use open API. Here you get things like the AR Raycast Manager, which is able to feed in data from our provider layer for all the different AR platforms that we support. And finally, we're developing packages. The Unity Package Manager allows you to implement and integrate all of the different XR platforms in an easy-to-use way. These packages allow us to update and add new features as the platforms evolve without having to wait for an entire update of the Unity core editor. And this has really allowed us to work much more quickly and efficiently as these platforms evolve. With all of the different partners we support at Unity, we have deep tested integrations for all of the AR and VR platforms, from ARKit on the Apple, AR Core with Google, Microsoft HoloLens and the Microsoft Mixed Reality, Oculus, PlayStation VR, and Magic Leap. And of course, these platforms and these features enable many different types of games and applications built with Unity. Things like Job Simulator, Beat Saber, Pokemon Go, the IKEA Place app, and Shop Architect, who's building augmented reality applications for use on construction work sites. Now that you know a little bit about Unity and how we're evolving our XR platform, let's dive in and start learning about the XR Interaction Toolkit. This is a way that you can easily add and start building interactivity into your augmented and virtual reality applications. The XR Interaction Toolkit covers both AR and VR. We're looking at platforms like mobile augmented reality, like ARKit and AR Core, head-mounted augmented reality, like the HoloLens and Magic Leap, and mobile or standalone virtual reality like the Oculus Quest, and high-end virtual reality like the Oculus Rift. Now, right now, we do cover tracked controllers, but we're also thinking about the future of input. As more platforms adopt things like hand tracking, there's also plans to integrate that into the XR Interaction Toolkit. Some of the core features included are things like physics interaction, which give you the ability to pick up and grab objects in a very intuitive and natural way. There's lots of parameters for tweaking things like the acceleration or how the object is tracked to your controller, so that you can adjust it for the application or the game that you're building. Next, we have native UI support. This allows you as a developer to create a world space canvas with anything from drop-downs, toggles, buttons, and more, and allow you to interact with them with your tracked controllers in virtual reality. And lastly, one of the example features is locomotion. This allows you to teleport and move throughout a space and cover a wider area than just the track bounds that you set up. All right, let's go ahead and get started in an empty Unity project setting up the XR Interaction Toolkit. The first thing I need to do is go to the Package Manager. From there, I can go Window, Package Manager. And now the XR Interaction Toolkit is currently in a preview state as of the time of this recording. So in order to find it, I need to go to Advanced, Show Preview Packages. From here, I can simply search XR. And here we have the XR Interaction Toolkit. Let's go ahead and install that. All right, now that I have that installed, we can start building out our example scene. Let's return to our scene view here. And now I'm going to right-click in the scene hierarchy, which gives me the Create menu. Navigate down to XR, and here I'm going to select between a room scale XR rig and a stationary XR rig. Now I'm going to choose room scale XR rig because when I set up my VR headset, I was able to map the boundary as well as map the floor. This is a XR setup for a VR headset that allows you to walk around in the space. A lot of VR headsets have what they call seated or stationary mode as well, where you stay in a single location. This is when you'd set up the stationary XR rig. So let's go ahead and set up our room scale XR rig. Now, you'll notice this creates an object here called the XR Interaction Manager, and this is what handles the interaction. From here we have the XR rig, which as you can see here has an XR rig component there attached to it, and you can see that the tracking origin mode is set to floor. It gives us a default camera Y offset, which is the average height. Underneath the XR rig, we have things like the camera offset, and then the main camera. Now, the main camera is just a normal main camera here in Unity, except it has one special component over here called the tracked pose driver. This is how we take the tracking data from our XR integration, or our VR setup here, and allow it to feed the tracking data directly into Unity. Here we're driving the position and the rotation of our headset to the camera within Unity. You can see we have it set up as a generic XR device with the pose source to be center eye, or HMD, head-mounted display reference. We're tracking both the rotation and the position, since I'm using a high-end headset here for this demo. Next, we're doing the update type on update and before renderer. Now, underneath the camera offset, there's also a left and right hand controller. And these are set up to have XR ray interactors, which allows you to interact with different objects within the scene at a distance. These are driven from a line renderer and have associated components and different properties depending on how you want them to look and interact. There's also the XR line visual, which drives the interaction between things like selection and invalid selection. Now let's go ahead and create a floor. To do this, I'm going to go back into the Create menu and create a cube. Now, in order for this cube to be correctly lined up with my floor, as I set up with my XR rig, I'm going to lower its value a little bit. If I turn to show it from the side here, you can see that it's intruding a little bit on this box that we have. And this box is representative of the XR rig, or the tracking space. So let's go ahead and move it down in the Y by 0.5 meters. From there, I'm going to expand it a little bit to be more representative of floor. So let's do that in both the X and the Z scale. Next, I'm going to go ahead and save my scene so that we can properly set up the lighting settings. File, Save As. We'll name it Demo Scene. From here, I can go into my lighting settings and generate the lighting to get the correct lighting setup. All right, now let's change the color of the floor a little bit. I'm going to right-click down here in my project hierarchy, go to Create Material. We'll call this one Floor Mat. Drag it onto the floor, and go over here in the inspector to change its color. All right, the last thing I need to do here is configure what we call the XR management in Unity. To do this, I'm going to go to Edit, Project Settings, and I'll dock this up here. Now, in the project settings, you can see here at the bottom, we have XR Plugin Management, and I'm going to go ahead and install this. What XR Plugin Management does is it allows us to easily manage and add different XR platforms into our Unity editor and allow us to create with those. What it's doing on the back end is it's actually integrating the different packages for these platforms that I talked about a little bit earlier in the presentation. For this demo, I'm using an Oculus Quest that is linked up to my computer via the link cable, which allows the Oculus Quest to emulate or act like an Oculus Rift on a high-end PC. So for this, I'm simply going to check the Oculus button, and now it's adding that Oculus platform and enabling the Oculus integration into Unity. Now if we go back to our scene view and we hit play, you'll see that our camera is now tracked to our VR headset, and it allows us to look around. Now let's go ahead and create prefabs that we can use to represent the controllers visually. Now, because the controller prefabs when they're spawned are set to 1:1:1 in the scale, we're going to create a small parent-child relationship in order to have a smaller primitive represent these controllers. So first here, I'm just going to create an empty object and call this controller prefab. Next, I'm going to create a sphere underneath this object. And let's make that a little bit smaller. Now we don't need a collider on these prefabs since it's all driven from the XR interaction. So I'm going to go ahead and remove this here, since these are just our controller visual representations. Now let's go ahead and drag this controller down into the assets folder in order to create a prefab. From there, we can delete it from our scene and go in our left and right hand controller and assign it here in the model prefab field. And there we go on the right controller. Now let's save our scene and go ahead and hit play, and we'll see a representation of our controllers. Great. Now let's go ahead and set up an actual interactable that we can start to grab. First, I'm going to create a small table. Now, for positioning this table, I want it to be in front of me so that it has easy access. So here, let's line it up a little bit with the ground and then move it forward here in the Z direction. This camera gizmo right here represents the center of my tracked play space and the actual headset itself. Because this cube is 1 meter by 1 meter, this is approximately 1 meter off the ground. And to keep things organized, let's go ahead and call this table. Now let's go ahead and create a smaller cube that we can actually interact with. Here I'm going to position this over the table and adjust its scale. Next, I'm going to add a rigid body, since we're going to be using physics to interact with this. Let's go ahead and create a material for this cube. And set its color to orange. And now we can simply drag and drop it to assign it. And the last thing we want to do is we want to enable the interaction on this. Now, our controllers already have the XR Ray interactor, so we just need to add an interactable to this cube. To do that, we can go to our Add Component, start typing Interact, and here you can see an XR Grab interactable. Let's go ahead and add that, and by now, we'll just leave all these settings by default. Let's save our scene and hop back into VR. All right, so you can see we have visual representations for the hand, and we can use these rays to actually grab the object at a distance. Once you see that, you can see that the object then becomes tracked or locked onto my controller, and we can use physics to then throw it and release it if we time our release correctly. These XR ray interactors are great for interacting and grabbing objects at a distance. And you can see that because we're just using the native Unity physics, it's easy to start grabbing and interacting with objects. Now let's get started in the XR World Interaction demo. This project is a part of the XR Interaction Toolkit examples, available on Unity-Technologies GitHub repo. Here you can see things like tracked issues, updates, as well as different branches that are currently being developed for the XR Interaction Toolkit and the example projects. Now, I've already cloned this repository to a project, so let's go ahead and hop in. Let's go ahead into the Scenes folder, and here we have the World Interaction demo. Now, this demo has various parts and has a small little example scene set up. Let's make the gizmos a little bit smaller so that we can see things. Alright, so to start, we have our XR Interaction rig here near the Welcome to XR Interactions toolkit. There are 3 different types of grab interactables set up for different tracking on how it relates to the actual tracked controller, with things like velocity tracked, kinematic, and instantaneous. Next, over here, we have an example of UI interaction. This is a native Unity world space canvas, and it shows you how you can use the XR Interaction Toolkit to actually toggle and manipulate these different UI elements. From there, we have the teleportation. This is a small example of how you can locomote around your environment and the different areas within the interaction demo. Next, we have snap interactions. This is an area where you can go and pick up objects, and each of these objects have what we call a snap socket, which allows you to place content directly back into a specified slot. Now, the cool thing with these sockets is that they actually give you a visual representation on the item that you're placing in the socket. And there's various parameters and things to hook up in order to assign what you want per the socket. And last but not least, we have the complex grab interactions. Here are different grab interactables that do things like change colors depending on the state that they're in, whether they're hovered over, grabbed, or released. And finally, a special interaction here, which is a bubble machine that allows you to grab this little llama, and when you have the object in your hand and hit an additional button, in this case the trigger, it'll shoot bubbles out of its mouth. Now let's hop into VR and walk around a little bit to show off the different spots. Alright, so here we are in the XR Interaction Toolkit World Interaction demo. You can see I have 2 tracked controllers and we can grab these objects. In my right hand, I have a direct interactor, and in my left hand, I have a ray interactor, so we can grab things from a distance. Here you can see slight differences on how these objects are tracked to the controllers. Because they're all physics driven, we can do things like stack them. Now I'm using what we call snap to turn, which is slightly moving the joystick in order to rotate myself. Here I've teleported over to the UI interaction, which we can then still use an XR ray interactor to manipulate and interact with these different UI elements. Now let's explore this teleportation area. Here I can move around with my right controller that shows a teleportation arc or parabola. You can see how I can quickly navigate to different areas. Now we're in the snap interaction area, which again provides this little snap interactions and what we call a socket for these different objects. Now all of these objects are just XR ray grabbables, so we can still grab them like normal. And you can see the sockets even work at a distance. Now let's look at these slightly more complex grab interactables. Here I'm using what we call the hover state in order to change its color. And here we have our llama, which we can then grab, and when we click the trigger button, it shoots bubbles out of its mouth.
Thank you very much, Dan, for the XR Interaction Toolkit walkthrough and showcase. Now, let's go through how the education content team applied this toolkit in Unity's VR Beginner project. Hi, I'm Jacek, part of the aforementioned team, and I will be showing you the 2 scenes we have prepared as part of the VR Beginner project, which will be followed by setting up an object to use within one of those scenes. Upon first opening the project, users are presented with a little instructional README file pointing them in the direction of our learning material and our forums. The learning material is a full project tutorial divided into chapters, leading you through setting up and modifying your very own VR scenes. On my screen right now is the first of those 2 scenes, a whimsical witch-themed escape room. Before I showcase a playthrough of this scene, I briefly want to show you the second scene we've prepared, and we will be taking a look at it later. That is the prototype scene. This scene focuses much more on realism and interacting with real-world objects. Such as hourglasses, fans, toasters, torches, and all sorts of other objects. But more on that later. For now, let's go back to the escape room scene and have a look at how the XR Interaction Toolkit was applied to create a light-hearted, accessible experience. Be warned that this following session will be a full walkthrough of the escape room, so if you wanted to try and solve it yourself, maybe skip ahead a little bit to the prototype scene. But for now, let's put on our VR headsets and enter play mode and see what this looks like from inside the headset. And we're inside. Now this project was designed and tested on the HTC Vive family of devices, the Oculus Quest, and the Oculus Rift family of devices. I'm currently playing this on an Oculus Quest attached to the computer through a link cable. And here we are inside of the scene. We can turn around with our head or use snap turning, which comes by default with the toolkit. It looks like we can't teleport anywhere yet, but we do have a set of instructions presented on the table. It looks like we can grab objects using the grab buttons, and it looks like we want to place a book on that holder over there. So let's turn around using snap turning, and oh, there's a radio. Let's turn that off for now. Let's try and grab one of these books and place it on the holder. Not only does it need to be a special book, we also saw a feature that we've added for accessibility. You can enable subtitles on any object to increase the accessibility of your project. I've picked up this smiley key, so let's put it into the lock and open up the drawer. There's the book we've been looking for. Place it on a little holder, and this has enabled teleport hotspots. Now these have been set up with the XR Interaction Toolkit as well, and they're one of the default functionalities of the kit. Let's teleport over there and inspect the door that we're trying to escape out of. It looks like we need a special potion to be poured down this hatch in order to escape the room. Now, let's see what's around us. There's quite a lot of stuff, but it looks like something's sticking out of that chest that might be interesting. Let's pick it up. Now, all of these objects have been created with the grabbable component of the XR Interaction Toolkit. This one freezes items in space when you let go of them, but for many others, you can simply throw them into our little happy fire. This looks like the recipe that we need to create that special potion that will let us escape from the room. Let's find a use for it while still holding on to it. Going to teleport over there. It looks like a cauldron, perfect for brewing potions. I'm going to let go and let it hover around. And it seems like we need something else to open the cauldron. Looks like we need our witch's wand. I know where it is, so I'm just going to go over and grab it from the shelf. Now, much like the instructions, this wand can also be let go to freeze in space. but this one has special functionality added, which we will be setting up later in the prototype scene. I can press trigger to fire off bolts anywhere I want. I think this will let me open up the cauldron. So let's try it. There we go. The cauldron is open and we're ready to brew some potions. And as we can see here, potions also have secondary functionality. We can press the trigger button to crack them open and pour some liquid out, which is very nice and exciting. But that's not the one we want. Let's make our special potion using these ingredients. We want a steak, a feather, and a pumpkin. I'm going to turn around, and we see another accessibility function that we've added. We can point the palm of our hand at certain objects and simply fly them towards us. Very handy. So let's grab that steak, throw it into our cauldron, and we see, once again, the subtitles letting us know what's happening. Now we need a feather, so there we go. And for the pumpkin, I'm just going to grab it normally by teleporting over, and let's go for this one. And then turning back around, and chucking it in the middle. Now we've got all the ingredients, but we need to set up the cauldron correctly. This is done using dials and sliders that are also set up using the toolkit. Let's turn this to 105, and let's make sure the cauldron spins right. And there we go, that looks good to me. We can finally press this big, enticing brew button to create our escape. Let's move this out of the way, and delicious. There it is. We probably shouldn't drink this, but let's take it over and make our escape. Now again, we can either pop the cork or we can grab it and pull it out with our hand. We don't need that, so let's pour that bottle right down the drain, throw it away if we don't need it, and we have successfully made our escape.
We have successfully escaped, but there are many other features to experiment and interact with in this escape room scene. So if you're interested, make sure to check them out in the project, or to follow the learning material and learn how to create or modify such scenes yourself. But now, let's take a look at a more realistic experience which we have set up, the prototype scene. The prototype scene comes with a simplistic, clean background and an assortment of realistic-looking objects to experiment with or set up yourself. Once again, the teleportation anchors and XR grabbable components from the XR Interaction Toolkit do a lot of the heavy work for us here. Not all objects presented in the scene can be interacted with. Some have been left for you to set up yourself. First, let's enter play mode and explore what's provided here for us.
Here we are inside of the prototype scene. As I said, simple and clean. Let's teleport over to the table where we have some interactables. Before we interact with any of these objects, I want to go over to the other hotspot where we have this realistic fuse box which we can fix by grabbing this XR interactable and floating it into place, much like Dan did in his video. We can now pull the lever and reactivate the fuse box. Over on the table, we have a whole assortment of objects that we can interact with, including this fancy light switch which we can rotate like we did with the cauldron. A lot of items here have secondary functionality. For example, when we pick up a torch, we can press the trigger to turn a light on and off. This simply activates or deactivates a light source. When we pick up this fan, we can press the trigger to turn it on. What a nice breeze. This drill, we can hold down the trigger and have it play an animation, where it's very clearly drilling a lot. Upon release, it stops the animation. There's of course the classic bubble gun, which shoots out bubbles when we press the trigger down. And lastly, not quite an interaction, but a fancy hourglass, which looks at the time passing. All of these items are very simple to set up. So let's go into the Unity editor and show you how you can set up your own item within a couple of steps.
Since we already have a shaking animation we used for the drill, we can reuse that animation to make the world's most powerful toothbrush. Now as we look at the drill game object, we see that it's made up of multiple children. The drill parent object contains a rigid body, which controls its physics, and the XR grab interactable, which does a lot of the work for us in terms of grabbing VR objects. Then we have the mesh, which simply displays the visual data. We have an attach point. This is the place on the object where the hand will grab it. So when we grab an object, this is the point we're actually grabbing it at. We've got colliders, so that the object doesn't just fall through the table. And the object activator script, which is what enables functionality when we press the trigger. Now, in our project folder here, we have a whole folder full of models which you can use, or import your own, of course. Let's find a toothbrush, and let's get ready to make the most powerful toothbrush the world has ever seen. So we've dragged in a model, and we need to set it up much like we set up the drill. So I'm going to go ahead and make the children game objects, which we need. This will need an attach point. We will need an object activator. We will need colliders. And we will need the actual mesh. That looks good. Now that we have all of these objects, let's focus on the parent once again. We don't want to be displaying the model or the renderer here, so let's remove those components. Instead, we would like a rigid body and the XR grab interactable. Now this script is what allows us to grab objects once we're in play mode. We can see here we have an attach transform. This is the point at which we will grab an object. As I previously mentioned, the attach game object. But before we do that, let's actually add the meshes so we can visualize the toothbrush and it's not just empty space. We need to load in the model by loading in the mesh filter and the mesh renderer so we can see it. For the mesh, let's select the toothbrush. There it is, all nice and pink. So let's give it some proper materials with the toothbrush material. There we go. Now we can go back to the parent object and focus on that attach transform. When we hold the toothbrush, that actually doesn't seem too bad. I might just lower it a tiny bit so we're holding it more in the middle of the object. Then I can return to my toothbrush XR grab interactable and drag and drop the attach transform. And that is now where we will be grabbing the toothbrush when we pick it up. Attaches in time looks good to me. That's how many seconds it takes for an object to attach to your hand. So 0.15 is pretty good. We want the movement type to be kinematic, as that's what we're using in the rigid body. And as for the interaction layers, all of these other settings look good. We don't want to mess with any of these, but you can. There's a lot of possibilities here. We will be adding an interactable event when we activate or press the trigger button. And this can be configured in any way you'd like for your own project. But we haven't set it up yet, so let's return to this shortly. For now, let's attach the actual object activator script to the object activator game object. Look for object activator and add the component. Now, this is a toggle, and you can choose to either make it a toggle or not, so as long as you hold down the trigger. On activated and on deactivated, we want two different things to happen. So, what we want to happen is we want the object to start shaking, and as I said before, the shaking animation is something that we have prepared for this project. In order to get that to happen, we need to go back to our toothbrush mesh and attach the shake object script. It was written by us. Movement shake strength 0.2 seems like a lot, but we are making the world's most powerful toothbrush, and the rotation shake strength might be just a little bit too high, so let's maybe lower that down to 2. Naturally, you can mess with these settings as you'd like. We can now go back to the object activator because we now have the script that we need to play with. So we can drag the toothbrush mesh into the object slot on both activated and deactivated. Now the function that we want is for the shake object to start shaking when we start,
And when we deactivate, we want it to stop shaking. Now that's all of the functionality already set up for us. The only thing left is to add colliders so that the object doesn't fall through the world when it spawns. For that, let's add a capsule collider. Now that's a little bit big, so let's make sure the height matches and that the radius matches as well. We don't have to be exact for this step, but obviously at home, you'll be able to make it more precise. One last thing we need to do before we can test our object is to activate it. So within our XR Grab interactable, we have a list of interactable events upon which we can act, such as when we hover over an object, when we select it, or in our case, when we activate it by pressing the trigger button. What we want to happen when we press the trigger button is for that object activator to activate. So we can drag the object activator and then make sure that object activator is set to activated. So now, when we grab the toothbrush that we have created, it's going to look out for interactable events, such as onActivate, which we have set up to talk to the object activator script, which on activation will in turn make the object start shaking, as we've attached a shake script to the mesh render of this object. When we press the trigger again, it will deactivate and therefore stop shaking. For our purposes, that seems fine. The toothbrush will fall over, but we can grab it with our hands. Now it's time to get inside of the game view and test what we've made. Now that we're back in play mode, let's try to grab our newly created XR grabbable object. We can pick it up and swap it between our hands, and we see that it always attaches to the attach point, no matter where we grab it. We can throw it in the air and catch it again. And when we press the trigger, it really does become the world's most powerful toothbrush. We'll definitely have to change those settings if you want to release this to the consumer market. But we saw how quick and easy it is to set up an object to be grabbed, dropped, thrown, and activated. All this with a simple few list of components which the XR Interaction Toolkit enables us to use. Teleporters work in the same way. These are pre-set up for us, and we can simply create copies of them and slightly edit their functionality to achieve the result that we would like. Thank you very much for being here and listening to this presentation. I'm going to give it back to Dan now. See you later.
All right. Now, in conclusion, you've seen that the XR Interaction Toolkit is an easy way to get started with building for virtual reality. It's easy to extend and customize XR interaction depending on the content or the application that you're developing. And lastly, make sure to check out the VR Beginner project on the Unity Learn to see a little bit more, as well as go over all the steps required to build what Jacek showed. We'll be hosting a Q&A on the forums, so be sure to join us there where we can answer all of your questions related to the XR Interaction Toolkit and getting started with Unity and XR. For additional resources, be sure to check out the XR Interaction Toolkit package documentation, the VR Creator Kit blog, which gives more overview of the Witch's Escape Room, and lastly, check out the EDU Oculus course that is a partnership between Oculus and Unity and gives a broad overview of many different areas of virtual reality design and development. Unity Learn Premium. Live sessions and on-demand learning resources available at learn.unity.com. Complimentary access for all users are available to Learn Premium through June 20th. Learn Premium, as well as Unity Learn, covers projects and examples for all levels of learners and creators for the Unity platform. Thank you very much. To find out more information, as well as follow up on all Unity content, be sure to follow the hashtag UniteNow2020.